Hey guys, for lesson number 5, we're going to talk about graphing rational functions. Now, this is a pretty hefty topic, so we're only going to do 3 examples, but all 3 examples will kind of cover the stuff you're going to see. But these examples take a little while because you do have to find like vertical asymptotes, horizontal asymptotes. You got to learn how to do that, how to find your x and y intercepts, etc. So I have to define all that stuff for you guys first before I can show you examples on how we draw it. Most of these are going to be curves, just so you know. So they're all going to kind of do these weird curves when we start graphing them. But for now, let's start defining a couple of things. Okay, so let's start off with an x-intercept. Now, if we want to find an x-intercept, we have to set y equal to 0 and solve. Okay? Now, whenever we do this, if we end up with a fraction, I'm going to put right here, focus on numerator equal to 0. Okay, if we end up with some kind of fraction, then just set the numerator equal to 0. Now, the y-intercept, should probably highlight that because that's pretty important for some of these things here. So focus on the numerator and making sure that that is equal to 0. Now, the y-intercept, we're going to set x equal to 0 and solve. Okay, so that's what we're going to do whenever we ask you to find the x and y intercepts. You set y equal to 0 and you solve. In certain cases, you just get your numerator and set it equal to 0. For y-intercept, you're going to set x equal to 0 and solve. Okay, now, if we ask you to find the vertical asymptote, okay, so the vertical asymptote, what you're going to do is you're going to set your denominator equal to 0, and whatever you solve for, let's say you get x equal to 2, that's where you draw the vertical line. Okay, so we're going to solve for x. Right, so now I don't want to say the hard part, but the tough part in having to remember the definition for the horizontal asymptotes. So I'm going to put this right here. Horizontal asymptote. Okay, so for a horizontal asymptote, there's actually 3 situations that could occur. Okay, so you could get situation number 1. If the numerator has a larger degree than the denominator. So if the numerator has a larger degree, okay, so numerator larger degree than denominator, okay? In other words, the numerator has, let's say they're all x's, has a higher power than the denominator does. Okay, so the numerator has a larger degree than the denominator, then there is no horizontal asymptote. And an asymptote is just like a vertical line or a horizontal line. Okay, so if the numerator has a larger degree than denominator, there's no horizontal asymptote. Okay, situation number 2. If the denominator has a larger degree than the numerator. Okay, so denominator larger degree than the numerator. Okay, then the horizontal asymptote is y equal to 0. So you're going to draw a horizontal line, y equals 0. Okay, and then the third part, the last part. Okay, so we found that if, in part 1, if the numerator has a higher degree than the denominator, then there's no horizontal asymptote. Part 2, if the denominator has a larger degree than the numerator, then the horizontal asymptote is y equals 0. Part 3 says, if the numerator and denominator have equal degrees, then, now let me give you a quick example of what this might look like. Let's say we have ax to the 5th plus bx to the 3rd plus cx plus d. And then on the bottom, we'll put ex to the 5th plus fx to the 2nd plus g of x. Let's say that's our equation. So forget about all the letters. Just look at the variables x and their highest power. You're going to notice that they have the same power of 5, right? So if that's the case, then the horizontal asymptote is a divided by e, whatever those numbers happen to be, the leading coefficients. Okay, so I'm going to put right here, then the horizontal asymptote is the ratio of the leading coefficients. Okay, so I know this one's kind of tough. It's hard to understand unless you see it. So we'll do one. Equal degrees, then the ratio of the leading coefficients. Okay, so all right, so we have a lot of stuff. Okay, but the best way to do this is to just actually jump in and see how it's done. So x-intercepts, you set y equal to 0 and solve. Y-intercepts, you set x equal to 0 and solve. Vertical asymptotes, set your denominator equal to 0. Horizontal asymptotes, you have 3 situations. And it's actually very easy, but there's 3 situations. Okay, so here we go. Like I said, we're going to do 3 problems. So example number 1, we're going to graph. So what we're going to graph is y equal to 2 over x plus 2. And as usual, I'm always going to give you guys an easy one, medium, and a difficult. Okay, so this is example number 1. So here we go. This is the way we're going to do it. First off, what I'm going to do is I am going to create a grid here for us. Okay, let me just kind of set it up. So it's 6 in each direction. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I won't do the other way, you just know they're negative. So here we go. Let's start off with the x-intercept. So for the x-intercept, you're going to set y equal to 0. So it looks like this. 0 equals 2 over x plus 2. Then you just get your numerator. Okay, your numerator only. Focus on that. And set it equal to 0. So in other words, 0 equals 2. Well, that's not true. Okay. That's not gonna be true. So that means that there is no x-intercept. So I'm gonna put there is no x-intercept. Okay, so I don't have to put a dot anywhere. Now, my y-intercept. I'm supposed to let x equal to 0. So y equals 2 over 0 plus 2. Well, that's y equals 2 over 2. So y equals 1. So that means that my y-intercept occurs at 0, 1. The reason why I know it's 0, 1 is because I let x equal to 0 and I got y equal to 1. So at 0, 1, I'm going to put a dot. Okay, remember there is no x-intercept, so I'm not going to put a dot there yet. But at 0, 1, I'm going to put a dot. So there it is. Okay. Now, next is vertical asymptote. So vertical asymptote. For the vertical asymptote, you're supposed to get your denominator, which is x, right here, it's x plus 2, and set that equal to 0. Well, when you solve, you get x equals negative 2. So I'm going to go to x being negative 2, and I'm going to draw a vertical asymptote. Okay, so here it is. Here it is at negative 2. All right, and I'll even label it for you. X equal negative 2. That way you know exactly what that is. Okay, and I'll even label that point that we have over here. It's 0, 1. Okay, now, last but not least, horizontal asymptote. Now remember, for the horizontal asymptote, I'm supposed to look at my original equation. So there it is, y equals to 2 over x plus 2, and ask myself the questions. Okay, does the numerator have a higher degree than the denominator? Well, the numerator doesn't have a degree. There's no variable there. The denominator has x to the first power. That has a degree 1. So the numerator does not have a higher degree than the denominator. The next question, does the denominator have a higher degree than the numerator? And the answer to that is yes. Okay, because the power on this part right here, the x plus 2, the highest degree is right here, x to the first. Okay, and on top, there is none, so that would be a 0. So it is true that the denominator has a higher degree than the numerator. So what happens if the denominator has a higher degree than the numerator? Well, part 2 says if the denominator has a larger degree than the numerator, then the horizontal asymptote is y equals 0. So I'm just going to write y equals 0. And let me draw that. That's basically the x-axis, okay? So here we go. Now, we've basically done what we could, okay? And now what we're going to do is we're going to have to draw our graphs, okay? Now, all of these graphs are going to kind of look very similar. They're either going to look like this. Let me kind of draw a little quick picture. They might look like this, or they might look like this. Now, of course, they could be shifted left and right, but they're going to look one of those two ways. Okay, so if you look, I got to pass through this point right here. Okay, so what I'm going to do is I'm going to start up here. Remember, the red lines are asymptotes. I cannot pass through those red lines. So I'm going to leave that line like that. Well, notice I'm basically doing this piece right here. Okay, the bottom on the right side on the bottom, that's what I'm doing. So I'm just going to copy another one like this. Now, if you want to be a little bit more accurate, you can create an X and Y table and get some more points, but we're just trying to sketch them here. So that would be pretty good for that. Okay, you're just trying to do a sketch of these graphs. Okay, so finding your X and Y intercepts, stuff like that, that's what you have to do for that one. So remember, the graphs are going to kind of look like this, okay, one way or the other. They're going to look one or the other way. So just know that. Now, that's how you do one problem. Now let's try to make another example that's a little bit tougher. Okay, so here we go, example number 2. And I don't mean tougher as in, oh man, the work's going to be so much more difficult. No, the work is going to pretty much be the same thing. It just looks like it's going to be way more difficult. And then the third one that we do, there's going to be something special that happens. So I got to make sure I show that to you when we do it. All right, so here we go. Okay, so here's my function. I'm going to draw a graph over here. Okay, so there we go. Let me just create my tick marks here. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Now we're going to start off just like we did last time. Our x-intercept. And to do the x-intercept, we set y equal to 0. Okay, and once you set y equal to 0, I told you to focus on the numerator. Okay, you're going to basically solve that highlighted thing. 0 equals x minus 1, so x equals to 1. That means that my x-intercept is 1, 0. Again, the reason why it's 1, 0 is because I'm supposed to let y equal 0, and I found out that x is equal to 1. So I'm going to go ahead and put that right here. Okay, so on my graph, here's my 1, 0. Okay, now my y-intercept. For my y-intercept, I'm supposed to let x equal to 0. So it's going to be 0 minus 1 over 2 times 0 plus 4. So if I solve this, I get negative 1 over 4. So that means my y-intercept is at 0, negative 1/4. 0, negative 1/4. So right here, and I'm just doing a guesstimate, all right? 0, negative 1/4. Okay, great. Let's check out to see what else we get for this. Okay, so we're going to find out the vertical asymptote next. So vertical asymptote. So vertical asymptote says get your denominator, which is 2x plus 4, and set it equal to 0. Set it equal to 0. Okay, so when I do that, I start solving, so I get 2x equals negative 4. Now if you divide by 2, you get x equal to negative 2. Okay, so x equals to negative 2. I'm going to draw a vertical line there. Okay, there's my vertical line. Now, I got to do the horizontal asymptote. So horizontal asymptote. Basically, we have to look at the definition, right? Y equals to x minus 1 over 2x plus 4. And we ask ourselves, does the numerator have a higher degree than the denominator? Now notice, this is x to the first, x to the first. So does the numerator have a higher degree than the denominator? No, it doesn't. They're both 1. The next question, does the denominator have a higher degree than the numerator? No, it doesn't. Again, they're both 1. So part 3 says, do the numerator and denominator have the same degree? Yes, they do. So then the thing you're supposed to do is say, okay, well then if they both have the same degree, then what is my horizontal asymptote? Well, you got to take the coefficients in front. 1/2. So y equal to half. That is my solution for my horizontal asymptote. Y, oops, using the wrong colors again. Y equals to half. So I'm going to draw a line at half that's horizontal. Now, we got to look at our graphs. Okay, remember, your graph is either going to look like this, kind of, or probably could have made this a little bit bigger here. Let me try that again. Okay, so notice how these points, so I'm looking at this right now. The reason why I see that is because I notice that these points have to connect and they're going to have to kind of curl away from these red lines. So it looks like the bottom picture right here. So that means that the other part has to be up there. And there's that graph for that function. Okay, so we did the x-intercept, the y-intercept, a vertical asymptote, horizontal asymptote. Notice the work that we're doing is not impossible. It's relatively simple. You just have to know how to put it on the graph. Okay, and then know which kind of things you might end up having, right? Like it's going to be one of these two types of graphs. So you have to decide which one is it. Okay, is it type 1 or is it type 2? Which one is it, right? Once you decide, then you kind of copy that picture onto your graph. All right, last example. So we're going to get y equal to x squared plus 2x plus, I'm sorry, it should be plus 3x plus 2 divided by x squared minus 1. Okay, so let me set up a graph here for us. And I'll kind of put the little marks on here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we're just going to kind of do the rest of the tick marks here just to make it look nicer. So x-intercept. So the x-intercept, okay, for us right now is going to be that we set y equal to 0. So there it is. I set y equal to 0. And then I'm supposed to focus on the numerator. Okay, so that means I get 0 equals x squared plus 3x plus 2. Now, if you use the x method, this will factor into x plus 1 times x plus 2, which means that x plus 1 equal to 0 and x plus 2 equal to 0 would be your answers. So we get a -1 and a -2 as our solutions. Okay, so that means that the point -1, 0, -2, 0 are my x-intercepts. Remember, the reason why it's a 0 is because of the fact that y has to be 0 in order for me to do this. Okay, now normally I would put these points on my graph, but there's an issue. Okay, the function up here, the y equal to function, can be factored, and I can cancel things out. Okay, anytime you see trinomials and things like that, pay attention to the fact that you might be able to cancel stuff out, and if you could, that could change what x-intercepts you have, what y-intercepts you have, etc. So I don't want to do everything all at once. Okay, so x-intercepts was first, so let's do that. We already did that, sorry. Y-intercepts. So for y-intercept, I'm going to set x equal to 0. So y equal to 0 squared plus 3 times 0 plus 2 over 0 squared minus 1. So y is equal to 2 over -1, which means that y is -2. So my y-intercept would be at 0, -2. Okay, now before I do my before I do my points on here, I got to do my vertical asymptote and my horizontal asymptote. So let's do that. Okay, so vertical asymptote. Now my vertical asymptote, I have to look at the original function. So there it is. And I notice the denominator is x squared minus 1. So I put x squared minus 1 and I set that equal to 0. Well, that basically means that x squared has to equal to 1. Now I take a square root of both sides. So I get that x has to be plus or minus 1. Okay, so a positive 1 and a negative 1. Okay, x has to be a -1 and x has to be a positive 1. All right, great. So we know that to be the case. All right, and then horizontal. So horizontal asymptote. We're going to look at our original function and we're going to see what has the highest degree. If you look at the function here, the highest degrees are tied. They both have the same degree. So therefore 1 over 1. Okay, there's no 2 or 3 or anything in the front. So we got to put 1s there. So that means 1 over 1. That's going to be your horizontal asymptote. So y equals 1 over 1, which means y equals 1. Okay, so great. We know that our horizontal asymptote is 1. Our vertical asymptotes occur at -1 and +1. I also know that my y-intercept is 0, -2. I know that my x-intercept are -1, 0, and -2, 0. So you might be wondering, well, then why didn't you automatically just start drawing stuff? Well, here's the reason. Okay, here's the reason why I didn't start drawing stuff. I look at my function. Let me rewrite it way down here. Okay, y equals x squared plus 3x plus 2 over x squared minus 1. And if I factor everything using the x method, okay, so here it is. Using the x method and difference of two squares, that's how I get x minus 1, x plus 1. You're going to notice that I'm going to be able to cancel this part. Okay, if I cancel that one, the x plus 1, okay, if I get rid of the x plus 1, that means that my only vertical asymptote is there. I don't actually have two of them. I only have one. It only occurs at 1, not at -1. So when you see this, the vertical asymptote there, that cannot occur. Okay, not only can that not occur, x cannot be -1, which means this point cannot occur. All right, so how do I draw this graphically? Well, here we go. We are going to draw -2, 0. So -2, 0 is right here. Okay. And then I'm going to draw my y-intercept 0, -2. So 0, -2 is right here. And then I'm going to draw my vertical asymptote x equal to 1. So x equals to 1 is right here. But we used to have two of them. Okay. We used to have two vertical asymptotes, one at -1. So this is what's going to happen. Well, I'll show you right now. But don't forget about this, okay? Don't forget about this. Then the horizontal asymptote is 1. So horizontal asymptote is 1. So how do I draw it? Well, you can tell that this line is supposed to kind of connect like this. Let me redraw that. Okay, and this one's supposed to go like this. But here's the deal. At -1, we were supposed to have like a line going down this way. Okay, so at -1, we were supposed to have a line going there, but it disappeared because we crossed it out. So what do? This is how we take care of it. We put an empty circle where that asymptote was erased. Okay, so we put an empty circle where the asymptote got erased. Let me try this again. All right, so where this little circle is, there used to be a vertical asymptote there, but it disappeared. Okay, since it disappeared, then that means you got to put a little circle that's empty right there. You still draw the graphs the same way, you just got to put a little circle. Okay, notice I never put a dot at -1, 0, okay, because it's not supposed to be there, right? So this dot right here is not allowed. Nothing at -1, right? The thing we crossed out. So we crossed that stuff out because we weren't supposed to have it. And the reason why we weren't supposed to have it is because of this right here. Okay, that's why we can't have it, because it got canceled out. So those are the 3 examples. Again, I know this one's kind of tough. If you have problems with it, please let us know. Contact your teacher. Let us know what's going on. That way we can help you guys out. Okay? Have a good day.